Hello everyone. Let us now discuss today's LeetCode POTD problem. Find eventual safe states. So, the first thing here we are given with the terminal nodes which are now degree of 0, which are not going anywhere. Like they are called the terminal nodes, and a safe node is called as where every path from that safe node it should be terminated to the terminal node, or it should come to another safe node. Now we need to find all the safe nodes and return them in a sorted way. The first node which is given to us, which is 0. Now the first path or all the nodes which can go from 0 directly is 1 and then 2, right? Now, from this one, it can go to 2 or it can go to 3. Like it can go to 2 or it can go to 3. And then from this 2, we can go anywhere, right? And from this 3, we can go to 0. This is all the paths for 0 to 1 to 2. Like uh, you can go to 0 to 1 to 3 and then to 0. Remember that you can go from 0 and then to 0, and you are not terminated at a terminal node. This path is not terminated at a terminal node, right? So remember this thing. Next, let me start with 1, and here I can go from 1 to 2 and then to 3, right? Now, from 2, I can't go anywhere as 2 is not having any out edges. Now, from 3, I can go to 0. And from this 0, I can go to 1. And also, I can go to 2. Right? Here, from 0, I can go to 1. And also, I can go to 2. Right? Here also, I got, if you see clearly, here also I got a cycle. I came from 1 and also ended with 1 in a path. Now, let me start with 2. I can't go anywhere from this. If you see clearly, all are in edges, but there is no out edge. So, this is a safe node. Let me consider this, sorry, let me consider this as a safe node, right? So 2 is my safe node. So let me come to this 3, and for this 3 I have a path to 0, and from this 0 to 1 and then 1 also to 2 and also to 3, right? So here again I got a cycle. If you see, observe clearly. Now let me start with 4. From 4, I got to 5. This is the only node which I can go directly from 4. Now from 4, from 5, I can go to 2, right? From 2, there is no outage. So it is ending at a terminal node. So this 4 is ending at a terminal. So let me write that 4 as a safe node. These are my safe nodes. And let me start with 5. From 5, I can go till 2, right? So this is also ending at a terminal node. So my safe nodes are 2, 4, 5, and at 6 I have no out edges. So 2, 4, 5, 6 are my safe nodes. But if I use a depth first search, so if you see I am starting from 0 and came till 1 and then to 3 and then to 0, and my uh, goal is to detect a cycle. If I detected a cycle for a node, then it is not a safe node. But if I didn't detect any cycle in the paths of that node, I can say it as a safe node, right? But how can we eventually solve this question? So let me do one thing. Here I have the same uh, edges and vertices, right? So I will be using a breadth first search approach. But wait, here you got 2 as a terminal node. So To know 4 is a safe node, I need to go to 5 and then I need to go to 2 in a breadth first search. But if I change this 2 to 5, that means if I reverse this graph, every node, every edge is reversed, then 2 to 5 and 5 to 4. So this 2 will be my safe node. Every node which is starting, right? Which is this 2 is end node. That means the terminal node will be our starting point. So from the terminal node, we'll be starting our breadth first search travels, right? So let me flip all these uh, edges, right? So it may take some time, right? Flip horizontally, right? Flip horizontally, right? If you want, you can skip this part, right? Flip horizontally, flip horizontal. Now you have reversed this graph from 0. You got this, right? I forgot this to flip, right? From 0 to 3. Okay, you got this 0. The first thing which I want to do in a breadth first search travel search, I'll be using a queue which will store all the nodes which are having here. This 6 is having 0 out degree, right? This 2 is also having 0 out degree, but this 4 and 5 is having out degree of 1, right? So I will push back 2 first and then 6. So 2 first and then 6. Now this 2 is having out degree to 1. This 2 is having out edge to 5. Now, let me say here, if you see here 2 to 5 and 5 to 4 and 2 to 1, these all 2 to 5, right? 2 to 5. That means here I am going to 5 and I am decreasing its out degree by 1. So let me firstly write all the out degrees for every node. Here the out degree is 2, here out degree is 2, here out degree is 0, right, 0. Now here it is 1, 2, 2, 0, 1, 1, 1, 0, 2, 2, 0, 1, right, from 4, 1, 1, 0, from 3, right, 1, and 4, 5, all also 1, 1, and 0. So what I am doing here is 2 to 5. That means all the nodes which are ending with this 2. If you see here, this 2, all the nodes which are ending this 2 with this will be marked as safe. That's why we have reversed this graph so that we can start from the terminal node, and all the nodes which are ending to this terminal node will be marked as safe, right? So this will be uh, came or marked to 0, then it will be true or safe. All the nodes which are having 0 out degree will be marked as safe. Now this 5 is safe, right? Let me push that back into our queue, and I will remove this 2 as I am searching or traversing that 2. Now, after that, you have another edge from 2. It is 1. So, 1 is having a out degree of 2. So, let me decrement to 1. And then it is having out degree to 0. Let me decrement to 1. Next thing, you have this 6, right? I have the out degree of 0 and there is no out edges. So let me remove that from my queue. I have traversed that. Now from 5 I have this 4. So that means every time you see from 5 you have this 4. That means This 5 is a terminal node and 4 is starting from this or terminating to this terminal node. So that's why I am making this graph reversed, and let me decrement this to 0 and push that back into 4. Now I am traversing 5, that's why I have cancelled out. From 5 I have only one out edge, that is 4. That's it. Now let me go through this 4. 4 is not having any any out degree. Now 4 is also marked as 0. Now if you see, you got this, see, 2, 4, 5 and 6. These are the only elements, or which are the vertices which are having, which are the safe nodes. That's how you solve this problem. So what is the first thing I did? Reversed and store the out degree. So if you see, I am storing the out degree from the original graph, not from the reverse graph. So I'll be storing this out degree, right? After that, I'll be maintaining a queue and push all the nodes with out degree is equal to 0, right? After that, I will traverse through every node. So by using while queue is not empty, go through or traverse neighbors and or decrement out degree by 1. After that, if this neighbor is having 0 as the out degree, then push that into queue. So this is how you solve this problem. After that, if you're also pushing that back, you need to make safe of the current node, like I should be true, and I will be traversing this safe. So firstly, let me do that. Safe is a vector of size n, and made everything as true. And like, first thing, it should be a false, right? And traverse this safe, and if I is equal to true, safe of I, right? Safe of I is equal to true, then push that into our answer. Push that into our answer. After that, push into answer, right? After that, we will be returning our answer. That's how you will solve this problem. So if you want this code, it will be given in my description. So I will be giving the submission link, so follow that. Thank you.